Okay, here's another problem about equally likely outcomes. Here I'm using a deck of cards. So I figured many of you might know this, and if you don't, you could probably quickly understand it, and if not, you feel free to skip it. But in a deck of cards, standard playing cards, or one set of standard playing cards, there are 52 cards. And you see here you have 13 different what are called denominations: ace, king, queen, jack, 10 down to 2. And then you have four suits. So you can make these different what's called hands based on the suits and the denominations. So you're dealt in one type of poker, you're dealt five cards. And then uh, one type of hand, which is pretty low down on the list of hierarchy of the power of the hands, is called a pair. And that is when out of the five cards, you have uh, two, exactly two of one of the denominations, and not three, not four, exactly two, and no other matching other denominations. So here's an example: three of clubs, four of hearts. There's four of diamonds. That's the pair. King of spades, ace of spades. Okay, so that's a pair. Um, so you can see by up here how many pairs there are. There's 13 cards. So for each denomination, I can have several pairs. And how many pairs can you have? Well, there's four suits. So you could have four, choose two, or six pairs with any one. Like you could have ace clubs, ace diamonds, ace clubs, ace hearts, etc. There's six for the ace, six for each. So there's 78 total um, two card sets that are pairs, and I have to consider what the other cards can and can't be. I can't have, say, I want a pair. I can't have an ace if I have another ace. If I have ace clubs, ace diamonds, that's a pair. If I have an ace of hearts too, it's no longer a pair. So you have to be a little careful of how we count the pairs. Okay, so we'll let's say find. So find. Does it already say that? No. Find probability of E, where E is the event. E is a pair. Uh, okay. So the key is all hands are equally likely. Once the cards are dealt fairly, assumed to be dealt fairly, and any exact set of cards that I put down here are equally likely. So let's start by saying this. Note this experiment or whatever, this sample space S has equally likely outcomes, has ELO, equally likely outcomes. All right. How many does it have? How many does it have? So S, size of S is equal to, well, there's 52 total cards, and I choose five, right? So there's 52, choose five. So that's N. So that's how many outcomes there are. And so now we just have to count E and divide, right? So what is the size of E? So to find, let's write some words here so we calm ourselves down, maybe have a drink or something too. So to compute E, to find E, note, yeah, so there are the 78 pairs. So there are, let's see, 13 choose one. I pick one of the denominations for the pair, and then four choose two for the suit combo. That gives me 78. Now for the other three, what should we do? Let's see. We're just going to write it down. There's not going to be a lot of computation. It's just going to be written down. So let's see, for the other three, here's the deal. Out of the other 12 denominations left over, you can have, you need to pick three to be represented, right? So it's a 12 choose three. Gives me the other three denominations. Now I don't want to go, yeah, so let's just do that. So for the other denominations, it's 12 choose three. But then say I have those three denominations, I can have any of the four suits for any of them, right? So this would be just 4 choose 1 cubed, basically. So let's just write 4 1 cubed. Okay. Pair hands. I know I didn't, there's no intermediate calculation really. I mean, we discussed combination and permutation in chapter 1. So I'm just writing this down. So that's your solution then. So let's actually do it. I think we can maybe do it out a little. So I get, so P of E, so is equal to 13 choose 1, so I have 13 times 6 times 12 choose 3. That would be 12 times 11 times 10 times 4 cubed over, I better not forget, I had a 6 down here from the choose 3, and now I have 52, 51, 50, 49, 48, and up here I have a 5 factorial, which I'll just write like this. Whoa, sorry. Okay, there we go. Now, lots of things will cancel. Okay, so on the next line, I'm going to cancel some things here. So I have the 6 is canceled, the 13 and the 4 will cancel. So let's just do that much. 12 times 11 times 10 times 16 times 120. And down here I got rid of the 6, the 4, and the 13. So I have 51, 50, 49, 48. More things are canceling, right? The 16 and the 48 cancel, the 10 and the 50. So I have 12 times 11 times 12 times 11. These are gone, right? The 10 and the, yep, 16, times 120. Down here I have 51, 549 times 3. This is equal to, okay, let's see. Let's keep going. So I have 4 times 11 times 24. I canceled the 5 and the 3. 51 times 49. And yeah, I could take a 3 out too. So I have 8 up here. 32 times 11. 17 times 49. Let me see the phone. We do this on the phone. We get, the phone's not working now. Okay, no, okay. We get, let's see, hopefully it's right. 32 times 11 divided by 49 divided by 17. Yes, it's right. It's right. I remember this. So it's 0.4226 about. Last digits rounded. Okay. All right. So little less than half chance to get a pair. All right. Well, if you like cards, you can. If you like poker, you can do this for all the different hands. Similar strategies for this. Okay, stay tuned. Watch the next video for the next example. There'll be 2 more. two more of these problems, then chapter 3.